Hello everyone and welcome to our first lecture on matrices. So let's start with the definition of matrix. So I would recommend you all to please write down the definitions of all the key terms whenever I basically ask you to do so. So let's start with the definition of matrix. A matrix is a rectangular arrangement. So this is the key word. A matrix is a rectangular arrangement of numbers, symbols, or expressions. We represent matrix by its identity. So the key is identity of a matrix. Usually we use uppercase English alphabet to define the identity of a matrix, and then equals to sign, and then open and closed parentheses or square brackets. Some examples of matrices are like A is equals to 1, 2, 3, 4. B is equals to 3, 4, 1. C is equals to 7, 1, 4. Or D is equals to 1, 4, 3, 2, 1, 5. So these are some kind of matrices which I wrote for you, and you can basically see all these types in our discussion. So let's start with the key identifier. So another question is, what is the key identifier of a matrix? In matrix algebra, the key identifier is its order. Alright, so what order is? The order represents the dimensions of a matrix, and we represent order by rows cross columns. So the dimensions are basically rows and the columns of a matrix. So rows means horizontal set of numbers, and columns means vertical set of numbers. So for example, we have a matrix 1, 4, 3, 5, 1, 6. So if we consider the horizontal set of numbers, we get 2 rows, and if we consider the vertical set of numbers, we have 3 columns here. So we can say the order of matrix A is 2 by 3, because order of a matrix is always written in the form of rows cross columns. So if we go to our previous samples of matrices, here we can say the order of matrix A is 2 by 2. The order of matrix B is 1 by 3. The order of matrix C is 3 by 1. And the order of matrix D is 2 by 3, because the D has 2 rows and 3 columns. Right? So this is about the key identifier of a matrix. So this key identifier is very, very important when we start discussing about the operations on matrices and different applications of matrices. So I will request you to please remember the key identifier, which is the order, how to write the order of a matrix, and it is always in the form of rows cross columns. Alright? Okay, so I'm repeating it again. Please note it down. It is important to remember the format of writing the order. You cannot write columns cross matrix. Sorry, columns cross rows. That's wrong, right? The order is always be rows cross columns. First rows and second columns. All right. Okay, so now let's start with operations on matrices. All right. Now we have four fundamental operations which we can apply on matrices. One is addition, second is subtraction, third is multiplication of a matrix by a scalar or a number, and fourth is multiplication of two matrices, right? Since addition and subtraction follow the same principle, we will discuss them together under one heading. All right? Okay, let's start with addition or subtraction of matrices. For addition or subtraction of two matrices to be true, the must condition is both the parent matrices must have a same order. What does it mean? So if we ask you to find a plus b, now here after executing a plus b, we will definitely get some resultant matrix. Let's name it C. So these two matrices A and B are considered as parent matrices. Alright, and the C is called the resultant matrix. So I'm repeating it again. Please note it down. For addition or subtraction of two matrices to be true, the must condition is both parent matrices must have the same order. So in this equation, if matrix A has order of 2 by 3 and matrix B has order of 3 by 2, then you cannot generate addition, or you cannot execute addition of these two matrices. So for addition to be true, let's suppose we have matrix A having order of 2 by 2 and matrix B having order of 2 by 2, then we can generate or we can execute the addition of those kind of matrices. And remember one thing, the key is resultant of two matrices should have the same order as that of parent matrices. So let's suppose we have equation A plus B is equals to C. Here A and B are the parent matrices and C is the resultant matrix. Alright, so let's suppose order of A is 2 by 3, order of B is also 2 by 3. In that scenario, we can say addition is true. After executing the addition, the resultant matrix should also have order of 2 by 3. Is it clear? Alright, so let's do some examples. Let's suppose we have matrix A is 6, 1, 3 and matrix B is 5, minus 3, 7. And we are required to find A plus B, B plus A, A minus B and B minus A. So let's start with A plus B first. Okay, in the first step, we need to check the validity of the addition, whether addition is true or not. For validity of addition or subtraction, the key is to identify the order of the parent matrices. A has the order of 1 by 3 and B has the same order of 1 by 3. So we can say that addition or subtraction of two matrices A and B are true here. Now key is how to execute the addition or subtraction. Remember one thing, when we define any matrix, that matrix has entries or elements like 6, 1, 3 are the entries or elements of a matrix A. Every entry or every element of a matrix must have some kind of address. So if you can see the 6, this 6 basically lies on first row and first column intersection. So we can say that address of this entry is 1 by 1. Remember one thing, method of writing the address is same as that of the order. Means we can write first the row number and then the column number. So if you can see this one basically lies on the intersection of first row and the second column. So we can say 1 has an address of 1 by 2. So similarly, 3 has an address of 1 by 3. So when we add or subtract two matrices, the key is to add or subtract the corresponding entries of both the parent matrices. Means we need to add or subtract the same address entries in both the parent matrices. So let's suppose in A plus B, if we consider 6, 1, 3 plus of 5 minus 3, 7. So we can say that 6 and 5 are having the same address. So we can say these are the corresponding entries and we need to add these two. 1 and minus 3, they have the same address. So we need to add those two corresponding entries. And then 3 and 7, they are on the same address. And then we have to add them together. So the resultant will be 11 minus 2 and 10. So this matrix is basically the resultant matrix. Alright, let's try part number 2, which is B plus A. I'm trying to basically derive some important result out of it, so let's wait for that. And B plus A, it should be like this, right? So when we add these two matrices, when we're trying to add these two matrices, we need to add the corresponding entries. So here, the result should be 5 plus 6, minus 3 plus 1, and 7 plus 3. So that means we can say it should be 11 minus 2 and 10. Now if you compare this B plus A resultant with A plus B resultant, there isn't any difference. So you can say, or you can conclude that now you need to write it down. Addition of two matrices always follow commutative property. That is, A plus B is always equals to B plus A. Means order doesn't matter in addition of matrices. Now, if you try to solve A minus B, A minus B means we need to basically subtract two matrices, right? Okay. Here we need to subtract the corresponding entries, right? So 6 minus 5, 1 minus of minus 3, and 3 minus 7. So it should be 1 1 plus 3 is 4, and 3 minus 7 is minus 4. So resultant of A minus B is 1, 4, and minus 4. Again, if you notice, this resultant shows the same order as that of the parent matrices. So the key is, in addition and subtraction, resultant always inherit the order of the parent matrices. Now, if we try to execute B minus A, so we need to write B first, right? And then A second, right? Now, we need to subtract the corresponding entries, or you can say the same address entries. So we can write 5 minus 6 minus 3 minus 1 and 7 minus 3, right? So it should be minus 1, minus 4, and 4. So this is B minus A. Now here you can notice B minus A is not equals to A minus B, and obviously it has to be true because subtraction never follows commutative property. Alright, so this is all about addition and subtraction of two matrices, or you can say two or more than two matrices. And in the next lecture we are going to talk about the multiplication of a matrix by a scalar, or multiplication of two matrices. Thanks for watching, and happy studies.